All right, 3-2, solving systems of inequalities by graphing. And so we're going to be getting equations and getting y by itself today. But instead of just equal signs, we're going to see greater than and less than. Now, you've already graphed inequalities. What we're going to start looking at is when you have more than one inequality. All right, and so we're going to jump into example one. I'm not going to do example one that's in the book on page 146. I'm just going to kind of walk you through what they do, and then I'm going to show you another problem or two, okay? But basically, here's what's going on. Whenever you're graphing, these are just two inequalities right here. They're both linear, all right? Y is greater than 2x minus 4. Y is less than or equal to negative 1/2 x plus 3. This y is greater than this. It's going to be a dotted line. We're going to shade above that line. Y is less than or equal to this. We're going to put a solid line when we graph it, and we're going to shade below the line because it's less than. So you can just kind of jump, and you can see right here in the book what's going on. So they've got the y equals 2x minus 4 line going. They did a dotted line because it was just greater than, and they shaded above the line. So this whole thing was intended to be blue. All right, you're like, well, it's green. I'll explain that in just a second. But all above the dotted line right here is shaded blue. And they graphed the second one. Y is less than or equal to negative 1/2 x plus 3. Y-intercept of 3, slope of negative 1/2, down 1, right 2. They put a solid line because there was an equal sign in the inequality. So solid line, and it was less than, so they shaded below. That shade should make all this yellow. Well, obviously, you know what happens when yellow and blue meet. They make green. The green shade right here is where the solutions come from for this system. So when we did systems of just equalities or systems of equations in 3-1, we just found the ordered pair where the lines intersect. Well, now we're talking about shading regions because we have inequalities. So this is kind of, think of this as being double shaded. It's yellow and it's blue. That's where the answers come from. Answers can also come from any ordered pair on a solid line touching the double shade. So all of this part right here, if you pick an ordered pair, those would be solutions. If you picked ordered pair on a dotted line, those would not be solutions, okay? If you picked an ordered pair in the blue or the yellow region and plugged it in, it would work for one, but it wouldn't work for both inequalities. And being a part of the system, the answers have to fit both inequalities. And then, of course, the stuff in the unshaded part would fit neither. So the only answers we're interested in, if you're asked to check for solutions for a system of inequalities, it's where the double shade happens and where a solid line happens touching the double shade. All right, so I didn't do that one. I am going to do guided practice 1A right here. And I've got y is less than or equal to negative 2x plus 5. And y is greater than negative 1/4 x minus 6. All right, those have got y by themselves, so they're going to be easy to graph. So let's go graph both of these. All right, draw your xy chart. Counting by ones is pretty generic. If you're going to count by something other than ones, make sure you label, but I'm going to assume that you're counting by ones when you make these. All right, let's do this first one. So if I'm going to graph this, I've got to graph the line negative 2x plus 5. So my y-intercept is at 5. The slope tells me to go down 2 and then right 1. There's my negative slope. Or I could go up 2 and left 1. So there's my 3 dots that kind of line it up. I'm going to put a solid line because I have an equal sign. So I'm going to draw my solid line down through there. All right, and then this graph says shade below it. Now I'm going to do that. I'm going to try to do the dual colored thing. So I'm going to take this blue pen right here and I'm going to shade below this line right here. Okay, there's less than or equal to the line negative 2x plus 5. All right, all the way coming up to the, notice it's a solid line. Okay, I'm going to graph the next one. So here, I'll come up here. This one's in blue. Now I'm going to graph y is greater than negative 1/4 x minus 6. So I'm just going to graph that first. Don't worry about the inequality just yet. So I'm going to go down 6. 1, 2, 3, 4, 5, 6. I'm going to put a dot. I know a little bit tough to see right there, but you'll be all right. Now the slope says that I can go down 1, right, 1, 2, 3, 4, all right? Or I can go up 1 and I can go left. 1, 2, 3, 4. Put my dots. Now if you'll notice, all right, I'm going to shade greater than, but I don't have an equal sign here, so this is going to be a dotted line. Going on and on and on and on forever and ever and ever, okay? If I need to continue this one further, I can. Now, when I shade this, all right, I'm going to shade this one in red, All right? I'm shading above this line because it's greater than. So above is technically all this. Okay? It's above the dotted line. Now, where does the double shade happen? It happens all in here. Where it's red right there and where it's blue right there. Okay? Making it darker, trying to make it a little bit purple. Didn't work out great. You can kind of catch what's going on. That double shade right there is where all the answers come from. So if we tested any points, like let's say we took the origin 0, 0, and I plugged it in, okay, plugged in 0 for x and 0 for y and did the math, 0 would be less than or equal to 5. That works. If I did the same point here and plugged in 0 and 0, okay, that would be 0 is greater than -6. That's true. 0 is bigger than -6. So anything from the double shade fits. Anything on a solid line touching the double shade fits. So all of this stuff right here would be solutions. But once we get on a dotted line, or once we get out of the double shade, those are no longer solutions to both inequalities. And they have to be solutions to both to be an answer. All right, let's go down to 1b. Let's look at what happens when they're not both linear. No big deal. It's a good review right here. Y is greater than or equal to the absolute value of x. Y is less than 4/3 x plus 5. We've got one absolute value and one linear. This is absolute value. That's just the parent function for absolute value, just a v. This is linear. All right, I'm going to go try to do the same thing with the pen. No, it ain't perfect, but you see what's going on. All right, so absolute value of x, the vertex is at 0, 0. Its normal width. It's equal to, so I can draw a solid line. So there's the absolute value. You're like, well, how do I graph greater than that? All right, I'm going to do this in blue. Well, greater than is above the lines. So this is greater than, all in here. And again, I can continue this graph on, right? Basically, there it is. That's greater than, so all the blue, and then the solid lines fit this inequality. All right, let's go graph this line. So I have a y-intercept at 5. 1, 2, 3, 4, 5. Put a dot. Slope says go up 4. 1, 2, 3, 4. Right 3. 1, 2, 3. Or down 4. 1, 2, 3, 4. Left 3. 1, 2, 3. There it is. It's going to be a dotted line because there's no equal sign. So my dotted line running through there. Something like that. The shade for this, I'm going to do in red, is below. It's less than this line. The shade for this is all down here. Okay? Now what you've got to remember is, technically this absolute value graph goes on forever and ever in that direction. So if I expand that to make it fit right, shade that in blue, all right? And remember, we're shading below this dotted line. You can see where the double shade is. It's going to be kind of following this right here. And I got to kind of continue this on. I know it's a little bit tricky looking. All right, a little bit close together, but you'll be all right. So all in here, all in there are my solutions to both graphs right here. I wish it looked purple. It doesn't look very purple. You'll be all right, okay? So on this solid line or in this double shaded part, those ordered pair fit both inequalities. If it's not in the double shade, it doesn't fit both. If it doesn't fit both, it's not a solution to the entire system, all right? Let's see what we got. Let's look what happens. Let's go to example 2 and see if something happens when they don't intersect, and something does happen, all right? So I am now just doing example 2. It says this. It says we got y is greater than or equal to x plus 5, and y is less than x minus 4. Now, if you know anything, if you recognize patterns at all, you ought to notice, without even looking at that graph, that the slopes are the same and the y-intercepts are different, so these are parallel. So there could be a chance that we have no solution. You could still have solutions depending on where the shade is, all right? We just got to be careful. All right, so let's go graph these. I'll drop it down a little bit so I got a little bit more room. I'm going to graph this first one. The first one's a solid line, okay, because we have an equal sign. So x plus 5 is a y-intercept of 5. Put your dot. Slope says up 1 over 1, or down 1, left 1. We said it's a solid line. Something like that right there. There's the line, y equals x plus 5. I drew a solid line because of the equal sign. Now let's shade. kind of keep it consistent. I've been doing the top one in blue. I'll do this in blue. Where is greater than that line? All above here. So any solution on that solid line or above it in the blue shaded part, which again goes on forever and ever above it, is an answer or a solution to this inequality. Not necessarily both, because I don't know where the other shade's going to be. All right, let's graph the other one. This says y is less than x minus 4. So we'll go down 4 to our y-intercept. Slope is up 1 over 1 or down 1, left 1. This is going to be a dotted line, right? Because there's no equal sign. Forgive Coach Lang's drawings, but those are parallel. No, it doesn't look perfectly parallel. That's all right. They're parallel right there in the book. Now I'm going to go shade this second inequality in red. So I'm going to shade less than or below that line down here. So I'm telling you, solutions for this system of inequalities come from where there's a double shade, like the double shade in the first example, or the double shade in this example. Is there a double shade there? No, there is not. So guess what? This answer is called, it belongs to the empty set. We're going to put, there's no solution to this. There is not one ordered pair that you could ever come up with that would fit both of those inequalities. So the double shaded region, where the solid lines touch the double shaded region, is where our solutions come from. If you have no double shaded region, you can't have a solution, right? So that's kind of how that works, and that's a good jump into this, coming off of systems of equations where we're just finding intersecting points. All right, if you have any questions, please get up or get me to your desk and get the help that you need to be successful on this. Stay on top of your daily work. You will have an assignment that goes with this. Make sure you're getting that stuff done. Thank you.